Good morning, everyone. My name is Catherine. I'm a park ranger for San Mateo County Parks, and this morning we're doing reading with the ranger from my house. It is the second week of our National Astronomy Week theme for our Reading with the Rangers. So I'm going to start out today with one of my favorite books from childhood, Goodnight Moon, by Margaret Wise Brown, pictures by Clement Hurd. In the great green room there was a telephone, a red balloon, and a picture of the cow jumping over the moon. And there were 3 little bears sitting on chairs, and 2 little kittens and a pair of mittens, and a little toy house and a young mouse. And a comb and a brush and a bowl full of mush. And a quiet old lady who is whispering, hush. Good night, room. Good night, moon. Good night, cow jumping over the moon. Good night, light and the red balloon. Good night, bears. Good night, chairs. Good night, kittens. And good night, mittens. Good night, clocks, and good night, socks. Good night, little house. Good night, little mouse. Good night, comb, and good night, brush. Good night, nobody. Good night, mush. And good night to the old lady, whispering, hush. Good night, stars. Good night, air. Good night, noises everywhere. And that was Good Night, Moon by Margaret Wise Brown. Okay, so we're still talking about Astronomy Week this week. I have a great book that I'm going to finish up with it's a really big book. I'm not going to be able to read it all. It's got a lot of great information about the night sky, everything that you would be curious about that's up there. So I'm going to just read a few different passages and pages out of there as our last book. But for our next, we haven't visited this book in a while. This is the book of nature poetry, and there's quite a few poems, as you can imagine, written about the night sky and the things that we can see up in the night sky. Things that people have wondered about for centuries, and so here's a few of those great poems. Old Man, Moon, written by Eileen Fisher. The moon is very old. The reason why is clear. He gets a birthday once a month instead of once a year. Then there's The Man in the Moon by Billy Collins. He used to frighten me in the nights of childhood, the wide adult face, enormous, stern, aloft. I could not imagine such loneliness, such coldness. But tonight, as I drive home over these hilly roads, I see him sinking behind stands of winter trees and rising again to show his familiar face. And when he comes into full view over open fields, he looks like a young man who has fallen in love with the dark earth. A pale bachelor, well-groomed and full of melancholy, his round mouth open as if he had just broken into song. That's The Man in the Moon by Billy Collins. Here's another poem by Eileen Fisher called Looking Through Space. If people are living on Venus and Mars and looking through space at the planets and stars, I wonder if Earth seems a queer sort of thing, with whiteness in winter and greenness in spring. And here's a poem called When I Heard the Learned Astronomer, by Walt Whitman. When I heard the learned astronomer when the proofs, the figures were ranged in columns before me, when I was shown the charts and diagrams to add, divide, and measure them, when I, sitting, heard the astronomer, where he lectured with much applause in the lecture room, how soon unaccountable I became tired and sick, till rising and gliding out, I wandered off by myself in the mystical moist night air, and from time to time looked in perfect silence at the stars. And the last one, or last two that I'll read, are all about one of my favorite phenomenons that happens on Earth. And when doing the project that I talked about last week, the solar system by scale to scale project that we have open at San Bruno Mountain, I learned more about this, and I also learned that other planets have this as well. This is the Northern Lights, or the Aurora Borealis. So the first poem is called Aurora Borealis by Stephen Withrow. Over the shores of Labrador, a certain rippling purple curtain scatters light throughout the night. Wait, the color's now a duller hue of violet turning blue. This arctic veil, a breaching whale, could peer behind and still be blind as anyone, the northern sun, has bent to drape her gauzy cape across the skies and left my eyes to stare and stare at the glittering air. And this one's called Northern Lights by J. Patrick Lewis. As self-absorbed and callow as a teen, he never gave a thought to purple, blue, pink, red, or any color in between. Amusements would appear, but they were few, till August heaved an easel in the sky, and color, modulating into hue, flew summer's spectral spectacle on high. So that's a few poems about the Aurora Borealis. It's not quite astronomy, but other planets have auroras, and one of them is Jupiter. And so there's a really cool image on one of the signs if you happen to go out to San Bruno Mountain and walk our solar system out there, that you can see an aurora on Jupiter, which is really pretty. Alright, so this next book is a really great book if you have a young person in your life that's really curious about the night sky, about astronomy. This is called A Child's Introduction to the Night Sky, The Story of the Stars, Planets, and Constellations, and How You Can Find Them in the Sky, written by Michael Driscoll, illustrated by Meredith Hamilton. It's a really nice book. I'd recommend you check it out. And in the front pocket, there is a star finder. And the star finder is really cool. What you do is they have these different dials that you can spin. I apologize for my video being inverted, but they have the months on here as well as the days and then the time of the day. So you would align it to, you can spin this around and then it spins these constellations in here around. And so you would align it to the day and time that you're looking for. So if we have November 21st, I'll align that with November 21st at 8 p.m. So if I happen to go out tonight at 8 p.m., this is what the stars would be in the night sky, the constellations we would be able to see. So you might be able to recognize, let's see, we got Ursa Minor, the Little Dipper, right there. And some other, Cassiopeia is another common constellation. So these are really cool star charts and it helps you find them pretty easily. You just hold them up to the sky and look up. You can also get the Star Walk app. It's a free app that you can get on your smartphone or any smart device, and it actually geolocates where you are, and if you just take your phone out and point it up to wherever you are, it'll show what stars you're looking at even in the middle of the day. So it's a great app to learn stars with, and it shows, the really cool thing is it will show you the constellations that you're looking at and why they were assumed to be like a lion for Leo, because it'll show how the early astronomers looked at those stars and they saw a lion formed from the connections those stars made. So it's a pretty cool app, and it's really fun to look at. Alright, so we're going to go through a few of these pages in this book. Again, it's really long, so I can't go through the whole thing with you in one sitting, but we're just going to talk about a few different things. So first off, astronomy is defined as the study of the sky and all of the objects and forces up there. So it's a pretty wide subject. The universe is, as we can see, here's a picture of the known universe. And in this picture, it is using, it's called a baby picture of the universe. It uses light from when the universe was very, very young, and the warmer spots are showing up as red, and the cooler spots show up as blue. Let's see. The universe is the definition of the universe is a great vast area where everything we know of exists, and sometimes it's referred to as the cosmos. So, very, very cool. Alright. And what is in the universe? Well, mostly what we can see up there are stars. Lots and lots of stars. And this page talks all about the life cycle of a star. So you might not know this, but stars are not permanent. They actually, they are born, they live, and they die, just like we do. And there's many different life stages of a star. And there's different ways that stars can appear too. So our star is considered, let's see what it is, say. Our star is considered I think it said it was a white dwarf. And there are stars that are super giants. They can grow 1,000 times larger than our sun. There's other stars that are super tiny and they appear to be blue in coloration. Like these ones are more blue. These ones are more brown. So lots of different types of stars. It's really cool. And what we see in the sky are stars from all over many stars across the universe from what we can see in the sky. And the interesting thing is when stars die, they experience an explosion called a supernova. And these are really brilliant bursts of light. And this is a picture of the gaseous remains from a supernova. Very, very cool. All right. So early humans created our calendars based off of the stars and the movement of the stars, and that's why the Chinese calendar has all of the different shapes. The Leo, the Pisces. Those are all constellations that are in the sky, and they appeared at different times throughout the year they appeared in better closer up so people could see them. So in this, it also talks to you about the sun, our sun, which is a star, and it talks to you about all of the great things, the eclipses that can happen. So this is a great image of the different eclipses that happen. And all the planets that revolve around our sun in our solar system. We have 8 planets and several dwarf planets. Pluto used to be considered a planet, but now is considered a dwarf planet. So now we don't have 9 in our solar system, we have 8 planets. And then it goes through all the different planets in our solar system, starting with Mercury. The cool thing about our different planets in our solar system is that they're all very unique. You start out with rocky planets in our solar system. The closer to the sun, we have 4 rocky planets, including ours. And then you get farther out, you have 2 gas giants. They're completely made of gases, nothing solid in them. And then you have the ice giants farther out. So made of different things. And they all have different cycles of rotation. So there's rotating, the planet itself rotates like we do. So when our Earth rotates around, one full rotation is a day. And then when it rotates around the sun, that's a full rotation is a year when it takes around when it goes around the sun. So lots of really cool things is that different planets rotate at different speeds and they revolve around the sun at different speeds too. So for example, Mercury, the length of their day takes 59 Earth days. That means that Mercury spins around itself, around its own axis, very, very slowly. Very slowly. But the length of their year, if people or creatures were to live on Mercury, the length of Mercury's year is only 88 Earth days, as opposed to our 365 Earth days it takes for us to have a year. So it's very interesting that each of the planets is very different, has a different speed of rotating around itself and also revolving around the sun. Mercury, this also talks about some of the mythology around the planets, and Mercury is considered a speed demon by the Roman sky watchers. So they named the god Mercury, also known as Hermes in Greek mythology, because he was very, very fast. He's also the representation of track athletes, the ones that have wings on their shoes and things like that, because he was the messenger. He would carry messages back and forth very, very fast. Alright, Venus. Venus looks like this. It's the next planet in our solar system. And Venus it's very hot on Venus. It's 850 degrees Fahrenheit, very, very hot. And Venus has a very long day. It also rotates very slowly around its own axis. It has 243 Earth days to equal their day, their rotation, which that's very, very slow. That's almost the length of our year it takes for them to rotate the planet around itself one time. But it actually takes their planet longer to rotate around itself than it does to rotate around the sun. So it's hard to to show this in a visualization, but if you have the sun here and you have Venus, it's rotating around itself, but as it's rotating around itself, it's also rotating around the sun, and it takes longer for this one rotation like this than for it to go around the sun like this. Very cool. Venus, early astronomers thought Venus was a really pretty, beautiful planet. So there's been a lot of people who have created a lot of great poetry and artwork around Venus. And it's also been associated with the goddess of love. So you might recognize some of these statues, the Venus de Milo, and lots of beautiful things. So people can be inspired by astronomy. They're inspired by beautiful planets, as we heard from the poetry earlier. Alright, so then of course we come to home sweet home, Earth. This is Earth. No place like home, it says. Earth is, our length of day is 24 hours, as we know, and our length of year is 365 days. We have one moon. The first two planets in our solar system are too close to the sun to have a moon. But as we'll see farther out, as we get farther out in the solar system, lots of planets have lots more moons than we do. So Earth is a really, really interesting planet as far as we know. It's the only planet that sustains life. We are far enough away from the sun that it is not too hot for life, and we're also not so far away from the sun that it's too cold for life. So we're in this perfect pocket in the solar system that we're able to sustain life, because we also have an atmosphere that we're able to contain heat in too. And the great thing about life is biodiversity. So it shows on the bottom of the page here all the different great animals that we have in our planet, all the different plants and insects and all the great things that we have. Those are all just found on Earth. Okay. The moon, our moon, it's pretty small, but it's actually about the size of what is it? Venus, I think. It's a little bit bigger than, a little bit bigger than Mercury. Mercury is about the distance from San Francisco to New York. If we were to measure it on our Earth, it's about 3,000 miles. And the moon is about 2,100 miles. So it's a little bit smaller than the first planet, our moon. And the moon is a very fascinating part of our universe as well, as a part of our solar system. Did you know that the moon is responsible for the tides of the ocean? So the moon's gravity pulls on the Earth, and it pulls the tides back and forth. That's why we have the ebb and flow of the ocean. Next planet in our solar system is Mars. Mars. So let's go through it. We got Mercury, Venus, Earth, Mars. And Mars is red because of lots of volcanoes and other rock that is covering the surface. It's full of iron, and it's covered with a grainy dust that's similar to the rust that forms on iron. That dust is what gives the planet its red color. Its length of day is pretty similar to ours. It's 24.6 hours. Ours is 24 hours, remember? And its length of year, though, is 687 Earth days. So it's almost 2 years worth of our years for Mars to rotate or revolve around the sun. But for itself to rotate around itself, it's almost about the same speed. But Mars is very, very cold compared to Earth. Mars' average temperature is negative 81 degrees Fahrenheit. That is too cold, very cold. Although, let's see, going back to Earth, I realized I did not say the average temperature on Earth. It's 59 degrees Fahrenheit on Earth, so that is definitely more comfortable for me. I wouldn't have to wear a sweater. All right, Mars is the only planet out there so far that we really think there could be evidence of life on, because there's the potential for there is carbon dioxide on that planet, and we've found frozen carbon dioxide because it's so cold. But scientists are still looking into the idea of life on Mars. Mars is also the Roman god of war, partially probably because the color of the planet resembles the color of blood. Let's see. Next planet in the system is our largest planet in the solar system, Jupiter. And Jupiter is if we remember, we talked about Mercury being about 3,000 miles across. Venus was 7,500 miles across. Earth was about 8,000 miles across. Mars was 4,000. We go to Jupiter for a whopping almost 89,000 miles across. It's huge. Its length of day, it's very big, but it also spins really fast. Its length of day is 9.9 hours. So if we're comparing it to Earth's length of day, the time it takes to rotate on its own axis, it's traveling almost 3 times as fast as Earth, spinning like this. Or spinning like this, rather. And then its length of year is almost 12 times our Earth time it takes to rotate around the sun, or revolve around the sun. And Jupiter has a whopping 79 moons. So compared to Earth, we have 1 moon. Jupiter is named in Roman mythology. He is the god of the. He's basically Zeus in Greek mythology. The same figure. He's the god of all the gods, god of the universe. Partially because Jupiter's so large and so bright in the sky. Very interesting. And Jupiter's very cold. This is the first gaseous planet compared to all of the rocky planets before it. Okay, Saturn is our next planet. Saturn has these beautiful rings, but it's not the only planet that has rings. It's just the one that we have seen or identify with most of the beautiful rings. And the rings are actually made up of rock and dust and ice that orbit the planet, and we see it. It's got a length of day that's about half of ours. It's 10.7 hours. And 29 Earth years it takes to revolve around the sun. It takes 29 of our Earth years. They have 53 moons on Saturn, and it's also negative 288 degrees. This is another gaseous planet. It's completely made of gases. Let's see. Got 2 more planets. Uranus. Uranus is a sideways spinner. So as I was talking about, we rotate on the axis around this axis this way, but it rotates this way, like a rotisserie, a chicken rotating on a rotisserie. And Uranus is one of the ice planets. It's very, very cold, negative 350 degrees Fahrenheit. It has a similar length of day as ours, is a little bit less, and it rotates around the sun, or revolves around the sun, every 84 Earth years. So for 1 year, in effect, the rotation around the sun would be a year. It takes 84 our Earth years for Uranus to rotate around the sun. And it has 27 moons. Neptune. is the last planet in our solar system, and its length of day is 16 hours compared to our 24. Length of year is 165 Earth years. So it takes 165 of our Earth years for Neptune to revolve around the sun. It has 13 moons, and it's almost negative 400 degrees Fahrenheit. Neptune in Roman mythology is the god of the oceans, like Poseidon in Greek mythology. And the cool thing about these planets is that they have storms on them. You can see this is a picture of a storm on the surface of Neptune. They have eyes, like Jupiter has this eye spot, this storm that's been occurring for over 300 years. It's been observed, the great spot on Jupiter. So lots of cool information about the planets and other things like comets and other galaxies that are beyond our own. And it talks about what astronomers do. Lots and lots of great information. And it talks all about constellations, which are shapes that you can find in the sky that are made up of different stars. So here's an example of some constellations. Right here you can see Orion. Orion is a figure, and here's his belt made up of 3 stars in the middle. That one's a pretty easy one to spot in the sky. Lots of great. Here's the zodiac. And it's all the different constellations that create the zodiac, like Aries, Taurus, Gemini. And they're more easily seen at different times in the year. And that's what divided up the year into a calendar. Alright, lots of great information. I can't read it all, but I would highly recommend checking out this book. It is called, I'll say it again, it is called The Night Sky, or A Child's Introduction to the Night Sky. It's written by Michael Driscoll. So I'd recommend checking that book out. As always, I recommend that you check out books from your local libraries. If you live here in San Mateo County, San Mateo County Libraries has an easy to reserve library system on their website, and you can just reserve books there and pick them up in person. They have them at the library at an easy pickup location outside. It's contact free, and then you can also drop them off contact free at the libraries too. You can get books and CDs and movies and all sorts of great media from the libraries too. So I also want to remind you that we have a great exhibit up at San Bruno Mountain that has a walk through our solar system. It's a solar system reduced to a scale that we can walk. It's reduced 670 million times from the size of the actual solar system down to about 4 miles. And you can choose to do the whole thing or only part of it, and you can walk from the sun all the way to Neptune and learn interesting things about each of those planets. So I want to thank you all for joining me today, and I'll see you again next week. Bye everyone.